The first trainer version of the B-58 was delivered to the Air Force in August of 1960. Its assignment, the training of Air Force pilots in the handling of the Mach 2 B-58. The trainer proved to be a dependable airplane from the beginning of its service. In the first 2 months of its service, TB-58 number 1 qualified 6 pilot instructors and 7 B-58 pilots. The story of how this special airplane came into being begins in August of 1959, when the Air Force assigned Convair the task of developing a total of 4 trainer aircraft. In the interest of overall economy, it had been determined to convert research and development aircraft to the trainer configuration, incorporating such alterations as might be necessary. As a preliminary step, a mock-up was constructed to show just how the conversion airplane would do the job. Incorporated were various changes arrived at through design studies. These included rearrangement of the second station, additions to the control system, as well as changes in instrumentation and cockpit lighting. The new second station occupies the space which formerly housed the electronic equipment for the bombing navigation system. This system, together with the active and passive defense systems, have been removed from the TB-58 as unnecessary for flights devoted exclusively to pilot training. The elimination of these systems brought about a considerable saving in the cost of the trainer. In the new second station, we find the pilot instructor's seat set 40 inches behind the first station and 10 inches off-center. In the bulkhead between the two stations, windows have been installed on either side of the ejection rail housing. In October of 1959, Research and Development Airplane number 11 was transferred from the flight test pool to the conversion program. With the acceptance of the elements of redesign required in the trainer B-58 by the Air Force, the actual conversion of a Hustler got underway. With the conversion work complete, Airplane 11 was ready for ground checkout. The schedule called for ground run-ups of newly installed engines, low-speed taxiing to evaluate ground handling characteristics and nose wheel steering, a high-speed taxi test to check the dual control system, brakes, and drag chute, and visibility checks from the second station. After satisfactorily completing its ground checkout, Airplane 11, now TB number 1, the first of 4 B-58 trainers, was ready for its first flight.
Roger, 670, you ready for takeoff? 670, roger. You take off on the right side of the active. The wind's 160 degrees at 5 knots, cleared for takeoff. Roger, advancing power.
On 10 May 1960, B-58 trainer number 1 lifted from the Carswell runway at a takeoff weight, lacking pod, of 97,000 pounds.
B-58.
Other Convair shakedown flights were scheduled for the trainer while carrying a pod.
You call high key. All right, you're welcome.
The crew performed regular test flight functions with emphasis on qualifying systems unique to the trainer, especially the dual control system. Transfer of flight control from station to station was practiced. In actual training, the pilot qualifying for the B-58 will get preliminary general indoctrination while flying in the second station, with the instructor occupying the pilot station. After this, the in-training B-58 pilot will move to the front seat for the major portion of his flight checkout, a procedure comparable to that employed in earlier aircraft having a tandem seat arrangement. The instructor in the second station will have, of course, an override capability at all times. While provided with these arrangements purely for training purposes, the TB has flying qualities identical to those of the operational B-58. For the prospective B-58 pilot without previous experience in Delta Wing aircraft, some readjustment may be required in his early acquaintance with the Hustler. But during his carefully supervised program, he will soon discover that the stability inherent in this platform, the ease of control augmented by its highly automatic equipment, the experience of sustained Mach 2 flight without strain, have given him full confidence in himself and his aircraft. With the imparting of this confidence, the chief goal of the non-tactical configuration of the B-58, today the TB-58 is achieving this goal quickly, economically, and dependably. Since the beginning of aviation history at Kitty Hawk, preservation of human life has been the airman's chief concern. Many methods have been used, from the early days simple parachute to the complicated high-altitude pressure suit of the 1950s. But in 1962, for the first time in history, the men who fly the supersonic airplanes have the means to save their lives without injury or appreciable discomfort when a disabled aircraft must be abandoned. This is one of the chapters in the story of Escape and Survive. In 1958, the decision was made to design and build an encapsulated seat for the ejection of an airman from the new supersonic Air Force bomber, the B-58 Hustler, manufactured by General Dynamics, Fort Worth. The job of design and development was awarded to Stanley Aviation Corporation of Denver, Colorado. From the beginning, many problems were apparent. After study and research, the control and stabilization of the capsule was accomplished by fins, which extended aft from the capsule, and a stabilization chute. The testing of many chutes in wind tunnel tests and high-speed sled tests resulted in the Hemisflow ribbon parachute. Thus began 3 years of intensive testing and retesting to develop the new capsule. Daisy track tests to develop harness and torso suspension devices. Supersonic sled runs to test ejection characteristics. Initial landing impact tests were accomplished by dropping the capsule to simulate landing rate of descent. Aerial drops from the Stanley T-28, testing flight characteristics. After the general configuration had been determined, the subsystems began to take shape. The Stanley capsule was designed to permit the airman the utmost freedom of mobility, comfort, and utility. It incorporates all the necessary features to assure absolute reliability and completeness of survival functions. During normal flight and mission time, it serves as an adjustable seat. Realizing that most pilots will never use the escape system for its primary purpose of escape and survival, it is unreasonable to encumber the airman with cumbersome pressure suits. By eliminating this, the Stanley capsule exemplifies the concept of shirt sleeve flying. The redundant capabilities of the capsule, opening and closing devices, permit fly down while doors are closed. The flight stick is an integral part of the capsule, and instruments are readily visible through the large plastic window. If the emergency ceases to exist, the doors may be opened and normal flight continues. While testing on the subsystems was being completed, more sled runs were made to test all systems during ejection. And a high-altitude drop from a B-47 to test the main recovery chute. Ground rocket firings were made to test the escape rocket used in the capsule.
A special structure was constructed at the Stanley plant to test landing impact. Under controlled conditions, the capsule was dropped on a variety of landing surfaces: dirt, concrete, and water. In early tests, animals were used, and later human subjects were tested. One of the prime requirements of the capsule is the universal survival capabilities. Over 50 pieces of survival equipment, including a 3-day supply of water and a 14-day food supply, are designed to fit into small containers tucked away in the capsule. Flotation tests were conducted under a wide range of climatic conditions from tropic to Arctic, including a survival test on Lake Erie in the dead of winter. The subject lived in the capsule 72 hours. During this time, he was subjected to severe Arctic conditions, sub-zero temperatures with ice forming on the capsule and buffeting of heavy seas. After the test, he was examined by medical personnel and pronounced hale and hearty. The final testing began with a static firing from a supersonic bomber parked on the runway. Next, a series of supersonic ejections were from a sled on Hurricane Mesa carrying animals. The mesa provides a recovery fall of over 2,000 feet at the end of the 2-mile track. Preparation for the tests are exacting. The rockets are installed and armed. The warning is given.
20 seconds till firing. 20 seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, fire.
Results showed no disabling injuries occurred during the ejections. After this, an operational capsule ejection was performed from an airplane rolling down the runway at 100 knots. This test emphasized the unique capacity of the capsule to eject and recover from a disabled aircraft during landing and takeoff. In February 1962, the first manned escape test was successfully performed above Edwards Air Force Base. High-speed cameras placed throughout the plane show with dramatic proof the Mach 2 capabilities of the only operational escape capsule in the world today. In high-speed regime, only a capsule can provide safe escape and confidence in the capabilities of survival. This confidence has been developed by an unprecedented number of test ejections with animals and humans. The Stanley capsule has completed all the qualification tests and is now operational. Thus, another important step is completed in air safety, and the practical application is made of escape and survive.
As the first airplane capable of sustained cruising at supersonic speeds, the B-58 presented a unique problem: how to escape safely in case of emergency from aircraft performing long-range, high-altitude military air operations. In solving this problem, several demands had to be met. The most important was the provision of a proper environment for survival during ejection, descent, and landing. In this last category, both ground and water landings had to be reckoned with, as well as a range of climatic conditions varying from tropical to Arctic. Other requirements were that the system should allow full in-flight operational freedom for the crew at all three stations and installation in the tactical aircraft with a minimum of modification. Going beyond these specifications, the Air Force and Convair, working together, hoped to provide a basic design of escape system capable of broader application than ever before envisioned. This meant discarding the design approach involving the detachment of an entire section of the fuselage for escape. It also meant that the ejection system evolved for the B-58 must fit the space envelope requirements for current conventional seats of any or all high-performance aircraft. A starting point was found in the ejection seat of some years ago. In line with the space envelope concept, an interim ejection seat fitting the conventional rails and requiring no change in the canopy or cockpit was developed for the B-58. This system incorporates several major improvements. One is the addition of extremity restraints, which will ensure far better protection against flailing after ejection than the current standard seat. Another is the replacement of the standard catapult by a rocket catapult to provide greater force for safe clearance. While the interim system remains just that, an intermediate step pending development of the fully perfected escape system, this equipment is currently the best available. Meanwhile, under contract from Convair, the Stanley Aviation Corporation of Denver, a small but highly capable concern, was awarded the task and is now designing and developing an escape capsule for the tactical B-58. Despite its present familiarity, that word capsule is still significant, for it embodies the principle of total encapsulation, which is the only possible answer for crew survival at the speeds of modern aircraft. Now, let's turn to an animated representation to see how the escape capsule, as installed in the B-58, will provide this maximum safety for all crew members, as well as accomplish other basic targets of its design. Again, using the conventional rails of the original ejection systems and requiring no major structural changes, the capsule has two configurations, one for the pilot station and another for each of the two crew stations. Their basic principle of operation, however, is the same. For purposes of demonstration, let's concentrate on the pilot station. As an example of operational freedom for the crew, the capsule, having its own pressure, oxygen, and recovery systems, eliminates the need for pressure suits, bailout bottles, and parachutes. Thus, the pilot and other crew members enjoy the same self-sufficiency at high altitudes as at low. This shirt-sleeve flying also contributes greatly to crew efficiency. Now, in slow motion, let's follow the pre-ejection and escape cycle. In case of high-altitude decompression, the pilot seeks immediate protection by closing the capsule. Note how the flight control stick, being an integral part of the capsule, permits control of the plane from inside the capsule. Another important advantage is that even with the capsule closed, he can still communicate with the second and third flight stations. Next, by means of push-button controls on the stick, he can move the center of gravity forward, retard the throttle, and fly down to a habitable altitude. Observe how the large front window allows him a view of his primary flight instruments. Once arrived at lower altitude, He may now raise the capsule door manually and continue flight.